Hello, and time for a science experiment. Okay, so I have to get really tricky with how I am able to view both my experiment items and my paper. So I'm going to try my best, see how it goes. You know, you always have to try. Okay, so the first step is I want to cut out the large rectangles on these two on this paper. So and then I need to open up my journal to my next available page. I'm sorry, we're in the science journal. Going to open up to the next available page. Here it is. Okay, and I'm going to turn it to make more space. I'm going to get a little closer. Okay, that's too close, of course. Okay, let me start there. Move this out of the way. Get out of the way. There we go. All right. So let's continue. So maybe you should pause me now so that you can cut out your two rectangles and I'll cut out mine and I'll see you back here soon. Oh, and we'll glue it together. Okay, here is how we are going to glue this. So take the paper that has more of the pictures on it. I'm gluing it at the top near the metal spring. And then I'm taking the other one. And I'm going to glue him towards the bottom. There we go. Okay, so here is my experiment explanation, and here is my recording sheet. Today we're talking about dissolving. So we have had our study of solids. We did an entire study of solids, including talking about 3D solids, and we've discussed liquids now, and we've discussed elements of liquids. So today we're going to combine those two studies into an experiment all about dissolving solids in liquids and kind of what that happens. So the first thing we need to do is we have all of this. Now I'm going to try to switch my screen so that you can see what you need for, okay, here we go. All right, so now this is a strange way to do it, but there we go, there I am. Well, we just have to get creative, guys. All right. So, oh boy, is that backwards? It might. That's okay. If it is, I can trust that you guys are able to write that correctly. So this is sugar, and what I did was I took a clear cup and I put about 2 tablespoons of sugar. I did not put an exact measurement, but I have 2 tablespoons of sugar. Okay, and I have about 2 tablespoons of rocks. Stole that from my fish tank. The fish were not happy. About 2 tablespoons of baking soda. And another 2 tablespoons of salt. Okay. I also have a spoon and a bottle of water that's easy to pour from. Okay. So now that we can do that, now I'm going to try to get small again. There I am. All right. So first, we need to talk and we need to perform the experiment with the sugar. So here's the sugar. I should have just done this, huh? Never mind. Oh well. So here I have my cup of sugar, just like we needed for dear old Granny's birthday cake. I might have been hanging out with the wolf this week. And what I'd like you to do is take your sugar cup, take your water, pour the water into the sugar, listen, and watch. Take your spoon, stir it up, and watch what happens. It might be hard to see with mine, but you could be doing with yours right now, and I'll help to describe what I see. So when I originally put the sugar in here, I could see the sugar at the bottom. It immediately went to the bottom because it's a solid and it doesn't float. But as I mix the sugar, it is completely mixing with the water. So this has now become a mixture called sugar water. And you can no longer see the sugar inside. So what happens is the sugar actually breaks down and conjoins with the water. The chemicals join and it becomes a mixture. Now, if I were brave or maybe silly, I would, and you can actually taste the sugar in the water. Don't do that with any other chemicals though, guys. And if you don't have an adult with you, I don't want to see you eating any of this, all right? Just wanted to, sometimes you have to be silly, but then you have to do a disclaimer. Okay, so this is called dissolving, when a solid completely mixes with a liquid. In this case, it's water. And when it mixes completely, you can no longer see it. So I'm going to put my sugar off to the side. Now, we're going to be scientists. In this box, it says, let's be scientists. And we need to circle yes or no. We want to know, will the baking soda completely dissolve in water? Will salt completely dissolve in water? Will rocks dissolve in water? Now you need to decide. If you think baking soda will dissolve, you circle yes. If you think it will not, you circle no. If you think salt will dissolve, you circle yes. If you think it will not dissolve, you circle no. And lastly, rocks. If you think rocks will dissolve, you circle yes. If you do not think so, you circle no. Now over here on our recording paper, we have baking soda, salt, and rocks. So let's see, Mrs. Smith is going to do this, and this, and this. Okay, so I think it will dissolve. Baking soda will dissolve. Okay, I think the salt will dissolve. And I think the rocks will not dissolve. Okay? You do not have to have the exact same answers that I do. The whole point of being an experiment, being a scientist doing an experiment, is that you have your own thoughts, and it doesn't really matter if it's wrong, because that's what being a scientist is all about. It's about trying things and getting things wrong and then fixing them and having your own ideas and your own thoughts. And when you are able to form those, you are able to have your own opinions and your own decisions. And that's really what makes you a smart person, is the ability to decide, and pros and cons, and a little bit like our lesson for history this week. Okay, next step, we are going to do our actual science. So we're going to take baking soda. So take your baking soda cup, put it in front of you. Take your water, carefully pour some water into the baking soda. Look and listen. Stir. Keep stirring. Keep stirring. Keep stirring. Probably about a minute, maybe 2. Terrible at figuring out times. All right, now take your spoon and scoop the bottom. Are there any solids left over? I kind of hear some graininess, but I don't see any solids. That's because this has become a mixture. The baking soda has mixed with the water to create a mixture. The baking soda has dissolved in the liquid. So, did the baking soda dissolve? Yes. Okay. Now we are moving on to salt. Oh, do not taste the baking soda. No joke. Don't do that. Gross. Okay. Moving on to the salt, guys. Put your salt cup in front of you. Pour some water. Listen. Stir. keep stirring. Okay. So as we continue to stir, we can then go towards the bottom. Might have to stir another minute or so. But you'll start to notice, especially if you leave it alone, and if you listen, we're hearing less and less of the graininess of the salt because, yes, in fact, the salt is dissolving. Now, last one, let's check some rocks. Water in the rocks. Stir. Ew, that's a terrible sound. Ah! All right. I can't handle that sound, guys. But I think we can safely say that these rocks are not going to dissolve in the liquid. So the answer is no. All right. So what's happening here? I'm going to try to explain it. This is not going to be a test. It's more like, here's something interesting, take it and use it. And then when you get older, you will have to begin to learn these things. So what's happening here is salt and sugar and baking soda. Oh, look at this, guys. That's the baking soda. It did not dissolve. Oh, it's a good thing we left our science experiment out. So what's happening here? Well, with salt and with sugar, eventually what's going to happen is that the water is present, all right? And the water is actually made up of molecules. You can't see them. They're really, really small. Salt is also made up of molecules, really, really small. You can't see them, but you can see the whole salt itself. When you mix the salt molecules with the water molecules surround the salt molecules, and they actually make them so that you can't see them anymore, and they become one molecule. And the water molecules and the salt molecules are together at that point. And that's why, and the sugar is another example, and that's why you can no longer see the sugar. You would eventually not be able to see the salt as well, because those molecules are going to surround it and eventually dissolve the original molecules so that all you see is the water. Now the rocks, the water molecules cannot separate the solid rocks. It cannot penetrate the chemicals of the rocks in order to separate them. And so this will remain like this forever. Okay. So I hope you've enjoyed our little discovery on dissolving. And I really like doing science experiments, so we should look forward to some more in the future. See you soon, guys.